Answers to assignment questions. Question 101. The question is quite the same as question 100, which you have done last time. There are also two objects that absorb energy during heating. Number one, water. Another, metal container. So this is how we find the energy absorbed by water. And then, for the container, the temperature change is the same. And so the total energy absorbed by them will be 41400 joule. So you may find the time of heating easily. Question 102. There is 5 kg of copper and 2 kg of water at the same initial temperature, 100 degrees Celsius. Which one may release more heat energy? The energy released will be given by heat capacity multiplied with temperature change. So when their temperatures drop by the same amount, then the one with larger heat capacity may then give out more energy. Question 103. In this question, there is an electric heater of power 250 watt, which means in each second, 250 joules of energy is supplied to the water. However, there is also energy lost to the surroundings, and that is 40 watts. That means 40 joules of energy is lost per second. In other words, the effective heating power is 210 watts. Multiply with the time taken, then you may find the energy given to the water. And so, in this case, you may find the mass of water using the equation Q equals mc delta T. Question 104. This is quite a similar question. So the power of the heater is 300 watts, and then the average rate of heat lost to the surroundings 50 watts. So the effective power is 250 watts. And then it won't be too difficult for you to find the time of heating from the formula. Question 105. Why the actual time of heating is even longer? In the last question, we have assumed that the power of energy loss is 50 watts, which is the power of energy loss at 30 degrees Celsius only. But now, the average temperature is actually 40 degrees Celsius. In fact, more than half of the heating time, the temperature is higher than 30 degrees Celsius. And so, the average rate of heat loss should be larger than 50 watts. In that case, the time of heating should be even longer. Question 106. It's good to find out most students know how to read the graph, and you may calculate the specific heat capacity from this or that point of the graph, which refers to the first and the second expressions. Both of them will give you an answer of about 1,300. Question 108. In this question, there are two liquids, oil and water. So which curve is for oil-filled radiator? Oil has a smaller specific heat capacity, so the temperature increases more sharply, and therefore water should increases more gently. So the dotted one should be for oil-filled radiator. Part B. Energy released by water when its temperature decreases. It shouldn't be too difficult for you. And now for part C. What is the energy released by water in 30 minutes? Look at this. In 30 minutes, water is heated once and it cools down once. So the energy released would be the same as the answer of question B. However, what about the energy released by oil in 30 minutes? Look at the graph above. In 30 minutes, what happened to the oil? It is heated and then it cools down itself. It is heated and cools down itself altogether 4 times. So the energy released by oil will be given by the mass of oil multiplied with the specific heat capacity of oil, temperature difference, and lastly, multiply by 4, as there are 4 different cooling curves for the oil in 30 minutes. And you may skip part E for that question. Question 109. In this experiment, we have no stirrer, but it does not affect the result because metals are good conductors of heat. Metals can conduct the heat very well inside the metal so that the temperature will be uniform inside the metal block. Question 110. So can we do the same experiment for glass? Answer is no, because glass is not a good conductor of heat, so temperature inside a piece of glass block would not be uniform. Question 111. Why we have to add a few drops of oil into the hose? Because the oil may improve the thermal contact among the metal block, heater, and thermometer, so that heat may conduct better. Question 112. The specific heat capacity of aluminium is in fact 900, but our experimental result is much higher because there's heat loss to the surroundings. So we have to supply even more energy. Question 113. So what's the improvement of the setup? To reduce the heat loss to the surroundings, we may wrap the metal block with cotton wool, or we may put a piece of foam or wood under the metal block to reduce the heat loss to the surroundings. Question 114. So 7,000 joules of energy is supplied to 3 kg of metal block. You may then apply the equation 9 and 7 to calculate the specific heat capacity in joule per kilogram per degrees Celsius, or calculate the heat capacity in joule per degrees Celsius. .4 Mixture is a calculation based on conservation of energy. In this section, we will mix hot and cold water or other liquids together, and we are going to find the final temperature of the mixture. As there is something hot, there's also something cold, and so the energy released by the hot object, the heat loss, will be absorbed by the cold object, the heat gain. That is to say, the heat loss by hot objects will be equal to the heat gain by the cold objects. And let's take a look of the following experiment.
Here are two empty polystyrene cups A and B. Measure the mass of each cup with an electronic balance. Then, half fill cup A with cold water and cup B with hot water. Measure the mass of the two cups again. Calculate the mass of water in each cup. Then measure the temperature of the water in each cup. Then quickly pour the cold water into the hot water. Stir the mixture. Measure the temperature of the mixture. Calculate the energy gained by the cold water and the energy lost by the hot water. Are the two results exactly the same? Why?